All right, we're going to go ahead and get started. We're going to be using the PowerPoint directly that goes with the textbook from Zumdahl Chemistry, Chapter 13, Equilibrium. And throughout this unit that we're actually going through, we'll be using parts of 4 different chapters. So make sure that you are taking your notes and keeping up with the information because it will be very, very important. Now, my goal also with this unit is to break up the section a little bit better than I have in the past. So this will be the first section of our PowerPoint and our notes. Make sure that you're reading your textbook along with it because there may be a few things that could be clarified even a little bit better. And remember, practice is going to make this unit the best possible for you. Now, we're going to go ahead and start with the equilibrium condition. Our first learning goal is going to be describe the concept of equilibrium and how it applies to our previous unit in kinetics. Now, if we can begin to make the connections, that will make our lives a lot easier when it comes to this. So, what exactly is chemical equilibrium? Equilibrium is the state where the concentrations of all the reactants and products remain constant with time. Now, most people will think when it comes to things being equal or at equilibrium, will think that means that the concentrations are all the same. But that's not exactly the situation that we have. We have a situation where the reactants and products concentrations are remaining constant over a certain period of time. Now, it's not something that's happening where everything, once they get there, just stops. We're actually looking at, and this is where it connects to our previous unit, where the rate of the forward reaction, which is what we're used to seeing, and the rate of the reverse reaction are the same. So while it looks like nothing is actually happening, what actually is happening is that you have a reaction going this way where products are being formed and it's being broken back down into the reactants and going back and forth. So this is very highly dynamic. Dynamic just means that it's changing. Now, it says macroscopically, and this is from our large view. If I'm looking at a beaker, it may seem like nothing's happening. But if I was able to look at it on the smaller level, it's very, very dynamic and it's changing a lot. Now, this is what we're used to, or sort of a graph of what happens to the concentration as the reaction goes on. If you notice, here on the bottom you have your ammonia that's being produced. And you see that it starts off at a concentration of 0 because we have none. This is actually called the Haber process. Now, starting off from nothing, you're also seeing that the concentration of your hydrogen and nitrogen are dropping. Now, the question you want to ask yourself, what do you notice about the concentration of your hydrogen as opposed to your concentration of nitrogen? What does this connect to and what we have talked about before? So that's just a little note. I'm going to ask you about that tomorrow in class. Now, if we take a look at what's happening at equilibrium, we said the concentrations reach levels where the rate of the forward reaction equals the rate of the reverse, as stated before. So you're looking at a graph that would look more like this. You have your forward rate that's coming in to play, as well as you have your reverse rate, which is the breaking down of these compounds. And it comes to a point where all of a sudden it stays about the same. This is the types of things that we want to look at and pay attention to as we continue on through this unit. Now, quick concept check. If we consider an equilibrium mixture in a closed vessel, this is the reaction that's going to actually take place. Water plus carbon monoxide breaking down into, or forming hydrogen gas and carbon dioxide, and also reforming back and forth. Now, if I add more water to the flask, how does the concentration of each chemical compare to the original concentration after equilibrium is reestablished? Now, you actually want to take some time and write this down to respond to this so that when you come into class, you're ready and you have something as a response. Second question, and this is where we'll end for today, looking at the same exact equation. How would it change if I was to add more hydrogen gas to the situation? How would the concentration of each compare to the original, and how would it adjust accordingly? So these are the things that we want to look at. This is going to come to the end of our first section. Write down any questions you may have. Continue to look over your notes, and I'll see you in class tomorrow. Have a great day.